Hello everyone, this is part 2 of Hess's law. In this video, we'll be going through the 2023 past paper on Hess's law. This is question 3C. In this question, we ask for the enthalpy change of the combustion reaction of glucose, which is here. The combustion reaction of glucose, which is reacting with oxygen, of course, produces carbon dioxide and water vapor, as shown in the equation below. And the data we get given are these 5. So one thing they've done is that they've given us the just the numerical values of those. But one good thing to do is to write down the actual chemical reaction or chemical equation of like the formation of glucose or the combustion of carbon, the combustion of H2, and the vaporization of liquid water. Alright, so let's write these 4 down. Let's write these 4 down. Alright, 1, 2, 3, 4. For 1, we have enthalpy of formation for C6H12O6 solid, which is C6H12O6, which is 6C solid plus 6H2 gas plus 3O2 gas goes to C6H12O6. This has an enthalpy change of -1270. Look at number 2. We have combustion. The enthalpy of combustion for solid carbon, which is CS plus O2 gas, and this goes to CO2 gas, which has an enthalpy change of -394. Look at our number 3, which is combustion enthalpy for gaseous H2, which gives us H2, 2H2 plus O2, or you could say 2H2 plus O2 gas goes to H2O liquid. Has a enthalpy change of -286. No, that's not right. Is that right? No, it's not, because the reaction is given above, which is H2 gas plus half O2 gas goes to H2O liquid, because this is a combustion reaction for 1 mole of H2 gas. And lastly is the change in vaporization of H2O liquid, which essentially is H2O liquid going to H2O gas. This has a enthalpy change of 6.01. Now that we have all these reaction equations, we can do from what we did last video to manipulate these 4 equations into these 4 equations, to manipulate these 4 equations into this reaction equation above, right? So let's take a look at these 4 reactions. I would start with of course this is a combustion reaction with glucose, so I start with the first one here, right, with glucose. So let's take a look. For reaction 1, we have glucose in the products and we want it to be in the reactants, so we just flip it over. C6H12O6 would give 6C solid plus 6 moles of gaseous H2 plus 3 moles of gaseous O2. And this will have a enthalpy of positive 1270 kilojoules per mole, because we flipped it. Now, again from last video, keep an eye on what we do want and what we don't want. Again, don't forget your state. We want the glucose solid. We don't want anything else from the products. So you're trying to remove essentially everything from the products. And we're gonna do this by again trying to find reactions that has these three species on the reactant side, because these three species right now is in the product side. Let's try remove the solid carbon first. I would use reaction 2 because that has solid carbon on the left hand side, the reactant side. So we're gonna add on. We're gonna add on 2, which is carbon solid plus O2 gas, which goes to CO2 gas. And we're going to multiply everything by 6 because we want to remove 6 moles of carbon solid. And this reaction 2 has an enthalpy of -394, and we have to multiply it by 6 because we need 6 times this equation, which is 6 times minus 394 gives us -2364. So this equation comes down to the C's cancel out. We get C6H12O6 solid plus let's see, 6O2. Oh, these cancel out and this becomes a 3 because we can remove the O2 gas as well, and this becomes 3O2 gas. This goes to 6CO2 gas plus 6H2 gas. That's 12. 6 is 12. 6 carbons, and 12 hydrogens. You can check the number of hydrogen, carbon, and oxygen for every line. And this gives us an enthalpy change of 1270 minus 2364, which is equal to -1094 kilojoules per mole. Now I have this reaction. Let's again look at what we do want and what we don't want. We do want the solid glucose. We need more oxygen. We do like the carbon dioxide, and we don't want the H2. So we don't want the 6H2 gas, and we will remove the 6H2 gas using the third reaction, which will just add it on because H2 is on the reactant side in the third reaction. Right, so we have H2 gas plus half O2 gas goes to H2O liquid, and we're gonna multiply everything by 6, so that becomes a 3, and that becomes a 6, because we want to remove 6 moles of H2 gas. Now these two goes, and we get C6H12O6. 3O2 plus 3O2 is 6. This is solid. 6O2 gas goes to 6 moles of carbon dioxide gas plus 6 moles of H2O liquid. And this, let's look at reaction 3, has a enthalpy change of -286. -286, and I'm going to multiply this by 6 because we multiplied this reaction by 6 times. So we get 6 times negative 286 equals negative 1716. And so this reaction here, the combined reaction has an enthalpy change of negative 1094 plus negative 1716, which is okay. We're gonna just do them. We're gonna write working down for the marks. 716. That's equal to negative 2810 kilojoules per mole. Now check again. What do we want and what don't we want? We're good with all of these, but this is H2O liquid, but we want H2O gas. So we're gonna adjust the H2O liquid using the fourth reaction, which is the vaporization reaction of H2O liquid, and this has a positive 6.01 enthalpy change. We're also just gonna add 4 on, which is H2O liquid goes to H2O gas, and I'm gonna multiply everything by 6 again because we're trying to remove 6 moles of H2O liquid. So we get 6 times 6.01 equals 36.06 kilojoules per mole for the enthalpy change. This comes down to C6H12O6 solid plus 6O2 gas. These two cancel out. Goes to 6CO2 gas plus 6H2O gas. Now, does this match everything up here? Yes, it does. And now let's calculate the enthalpy of combustion of this whole equation, which is negative 2810 plus 36.06 gives us negative 2810 plus 36.06 is negative 2773.94 kilojoules per mole. And we'll round it to 3 sig figs, which is 2770 kilojoules per mole to 3SF. And this is the whole rundown of the second part, which is the 2023 question 3 part C. This is an excellent question. Right, so for achieved, correctly manipulate 2 equations or enthalpy changes. So up to here, right? I'm gonna so anywhere up to here is achieved. And for merit, correct process with 1 error. So any error, any correct process, so everything right, but with any error, any 1 error in between, will give you a merit. And correct answer with units, sign, and significant figures. So units, sign, and significant figures, as well as any arithmetic mistakes, will bring you down to a merit. Right. Embarrassingly, this is a negative. But yeah, we'll ignore that. And so we got the sign, we got the numerical value, we got the units, and we got the significant figures. This will give you a E. If you, yeah. Thank you for watching. And yeah.